All subsystems report. Spacecraft is ready for EDL. Goldstone and Canberra are locked on. MGS is ready to support UHF link.
Navigation reporting the crew stage has been jettisoned properly.
Nav is go for EDL.
Copy that. Mission is flight.
Go flight. Flight nav.
Go nav. EDAs are running and recording.
SSC disconnect enable on.
35. Let guys go.
Water. It is the key to sustaining life here on Earth. Without it, we couldn't exist. Our planet dwells within our solar system, located in the outer reaches of the giant Milky Way galaxy. One of our neighboring planets, just 35 million miles away, is Mars. Nicknamed the Red Planet, Mars, out of all the other planets, has developed the reputation of having the best chance to find life. Or is it still possible? A few years ago, NASA and the Jet Propulsion Laboratory, or JPL, in Pasadena, California, dispatched 2 rovers fondly dubbed Opportunity and Spirit to our neighboring planet. These twin rovers were sent to opposite sides of Mars at the beginning of 2004. JPL's Mars Scout Program Manager, Steve Matusik.
The project started back in the year 2000, although some of the hardware and the rover components that the rovers built up from started as early as 1998. So it takes many years to put these missions together and conceive them and then get them launched. And then you start seeing the scientific results coming back.
Prior to their launching about 4 years ago, the 2 rover projects began back in 1998 with components and swung into full throttle in 2000. At the Mars Exploration Rover Assembly and Testing Compilation, workers painstakingly assembled parts and pieced the rover together. A gigantic parachute was sewn together at the Jet Propulsion Laboratory, then deployment was tested in the large open warehouse facility at the Ames Research Center. Protected like surgeons, the staff worked on and tested the rovers.
TC, once again, let you know this command will fail. The status -1 is installed. Finishes as expected.
As the rover sped towards Mars from Earth at a rate of 11,000 miles per hour, a speed that would allow one to cross the entire continental United States in less than 12 minutes. The crew was standing by with intense anticipation. Now, it typically takes a year to get to Mars from Earth, but these rovers managed to arrive in just 7 months. As each step came to fruition, the staff at Mission Control became more and more ecstatic. All their hard work was being put to the test during these crucial moments.
They took roughly 7 months to get there, and this is a quick time for Mars exploration. This is a really good opportunity. Earth and Mars are in different places, of course, as they orbit about the sun, and sometimes it's better than other times to launch. Typically it takes about a year, but this was a really good opportunity, so we got there in 7 months. The first criteria on sending a rover to Mars is you want it to be safe. So you couldn't send it just anywhere. You had to pick a safe place, and it had to be a place where the scientists said, we have the potential for discovering some things. So they picked, Spirit went to a place called Gusev Crater, and that particular site has, if you look at it from orbit, we have some orbiters there now, Mars Global Surveyor and the Odyssey orbiter. Those orbiters have seen in pictures that Gusev Crater looks like it used to be covered by an ancient lake. Now, you can't really tell that until you go down there, put your instruments next to it, and see what's there, if there's sediments, other clues. It's like a big detective story. They sent Opportunity to the other side of the planet because there's another area that was very flat and safe, but it had a characteristic that it had a lot of hematite. People say, well, what's hematite? It's basically this gray rock that on Earth can form in the presence of water under a lake or in a lava flow. Now, since we're trying to find if there was water present on the surface of Mars for an extended period, that seemed like a great place to go because the hematite could have been made by water, and that would be a huge discovery if we discover that.
Many scientists believe that Mars was comparatively warm and wet billions of years ago, before the planet lost most of its atmosphere. But with temperatures between minus 200 degrees Fahrenheit in the winter and just 30 degrees in the summertime, that's 0 degrees Celsius. Has life ever been able to survive there? Just half the size of Earth with no oceans, Mars contains about the same amount of land as we do. Mars boasts about 1/1000th the amount of carbon dioxide as Earth, while another important element, iron, has been detected within its 4,000-mile-plus diameter.
There's mostly iron and silicon, which are the basic building blocks of most of the rocks on Earth too. So it's very similar that way, but we haven't found a lot of these things like gold and other elements, probably because on the surface it's hard to just, on the Earth, if you just went down in any one place, you wouldn't see things like gold or other metals. So as we look at under the surface in future missions, I think we'll probably find some of those kind of things. It's a mystery as to how Mars compares to Earth too, in terms of what basic building blocks does it have. That's another reason that we go to Mars, is that we can compare it to the Earth and we learn more about the Earth. When they look at something outside the Earth, they say, oh, okay, this is different than where we're at here on the Earth. Why is that? So Mars is a very good place to learn that kind of stuff. Mars is the closest planet to the Earth. Venus is also close. Mars has a lot of carbon dioxide in the atmosphere, but it's very thin. If you were standing on the surface of Mars, the atmosphere is about 1/1000th the atmosphere here on Earth. So it's not a lot of atmosphere. It's enough so that it can slow us down so we can land safely, but not, and it's enough. They have huge winds sometimes that kick up on Mars. You see dust that goes into the atmosphere, but it's really not a very thick atmosphere. It gets very cold at night. The atmosphere on Earth here protects us at nighttime so it doesn't get so cold. On Mars, it gets much colder at night. It can get down to minus 100, minus 150.
As the first rover approached the Martian atmosphere, the parachute expands. Every step executes as planned. And finally, massive airbags are exposed, cushioning the rover as it bounces around on Mars, landing safely. Back at Mission Control, the crowd became overwhelmed with joy and excitement as success was evident.
We're seeing it on the LTP. Very strong on our LTP.
We have a very strong signal in the left-hand polarization channel, indicating that we still have a safe
We're getting
lander.
a signal on RCP as well.
We are
Both channels.
Upon landing, each rover begins unfolding itself to begin exploring its new home. While on Mars, Opportunity and Spirit will power themselves utilizing their solar panels during the day.
On the rover, you can see in back of me here, you see there are some flat surfaces that looks almost like a wing. Those are solar arrays, and so we're powered by the sun's energy. Just like on the Earth here, you'll see as you're driving along, you'll see these solar arrays that are on boxes and things like that. We get solar power, so during the daytime, we get power from the solar arrays. At nighttime, the rover survives by getting power from the batteries that are inside. And it has to stay warm too, because the electronics don't like to get really cold, so they have a heater inside and batteries.
After a month and a half of sitting out raging dust storms, both Spirit and Opportunity resumed driving around, exploring, collecting data, and communicating to Mission Control daily.
Currently, their best guess at the mission lifetime is about 90 days. Now, they could last longer. Pretty much the limiting factor in that is these daily cycles of hot and cold that go on at Mars. These daily cycles of hot and cold tend to limit the mechanical and electronic parts on there, just like they do on the Earth. You know, when you have something and you take it inside and outside, it'll break eventually. So that's part of the mission, is how long will they last. And with 2 rovers, we don't know how long each one's going to last, but they'll have twice as much results coming back during the lifetime of the mission. During Mars winter, it gets even colder, and there's not enough solar power. Just like in our winter, the sun gets lower on the horizon and you don't get warmed up as much. That'll happen with the solar rays. We get less power, which the batteries at night can't keep it warm enough, and that's probably the way that things will fail. What protects it is they have insulation in what they call a warm box inside, and they have heaters around the outside, so they put all the electronics that need to stay warm inside that box, and that keeps it warm at night. Now, when I say warm, I mean it might be -20, so it's all relative there.
The rovers operate on memory and are adaptable to alterations if necessary. Both rovers also conducted general atmospheric science, including characterizing dust on their panoramic camera. Just 2.5 hours after landing, Spirit was sending the highest quality photos ever taken of Mars. With rocks likened to serving as windows to the history of the red planet, the quality of images transmitted through radio wave signals back to Earth at the speed of light, about 9 minutes, then processed, are described as outstanding.
This is outstanding. This couldn't possibly be better. Everything is going perfectly tonight. The hardware is working perfectly on the surface. It's doing exactly as planned, and the images are outstanding. The quality of these pictures are the best that have ever been taken. I mean, they're fantastic. There's detail there. They're rich targets.
Sometimes you get information back, or you're going to send some, mostly when we'll get information back from the rover, it takes us a while to process it and put it into some format that we can understand, because basically what we're sending over radio waves are a bunch of ones and zeros. And so humans, you know, you can't look at a series of ones and zeros and say, aha, that means the temperature inside the rover is, 5 degrees. So we have other computers here on the Earth that are taking this information and they translate it, and that sometimes takes a while to happen. I'd say, it can take anywhere from a few seconds up to several hours, and then the engineers need to analyze this information, the engineers and scientists. The ability to control the rover is one of the things we have to have. Now, when you do that, a lot of people think of, okay, I've got a joystick and I'm driving it around. Well, we can't do it like that, because it takes anywhere from 9 minutes to 30 minutes for a signal that leaves the rover to come back to Earth at the speed of light. So if you had a joystick, you'd make a movement, and then 10 minutes later it would move, and so you couldn't really figure out how to drive around that way. So what we do is we call sequences of commands that get loaded into the memory, and then they execute over time. We have the capability to send signals there to alter things if we see something going wrong. This is a lot like, if you're running a software program on your computer and you start it up and then you tell it to do something, it'll do it, but there's a time delay in there. So we're controlling the rovers like that.
NASA's Mars Exploration Rover project began delivering data with the first mobile laboratory on Mars performing robotic geological fieldwork that could reveal a history of water on our neighboring planet. A rover has planned a mission to the North Plains on Mars, where there may be ice, which is of course frozen water. Opportunity and Spirit will actually be probing underground on Mars later on, equipped with radar to see below the surface.
Right now we're in a phase where we want to find out what water is doing now and what it's done in the past, because water seems to be the key to life, really. If on Earth, whenever we find life, there has to be water there. So we're thinking if we find the story of water, we know there's water at the poles right now in the form of ice caps, but is there water below the surface? 1 billion, 2 billion years ago, was there water on the surface of Mars? And so we're trying to find out those clues right now for water. As we find out about the water and how it's what it's doing on Mars, that will give us more clues to, is there life on Mars? Was there ever life on Mars? Which is one of the big questions we're trying to find out.
Fast forward to late summer 2007. Both rovers are still going strong. Spirit's odometer reading was over 7,000 meters, or about 5 miles by the end of August this year, and Opportunity had clocked well over 11,000 meters, more than 7 miles since landing on Mars in 2004. Which brings us to the question, will Spirit and Opportunity ever come back home?
The rovers are designed to not come back to Earth. It's a one-way trip. There's really no reason to bring them back to Earth. Once they're designed to go and rove on the surface of Mars, put their instruments down, make contact with the soil and the rocks, and so there's no reason to bring them back. In fact, it would take a lot of energy to bring back the rovers from the surface of Mars, because Mars has gravity about 1/3 the gravity of Earth, so you'd have to launch from the surface and bring them back. Another part of it is that we don't need them to come back is because they're robots. If we were humans going there, of course they'd come back, but when we send robots, we send them usually to go there and then do what they need to do, and we don't need them to come back.
Future missions also include bringing back to Earth rocks and dirt from Mars.
Now we have some future planning that's going on now for maybe sometime next decade to bring back rocks and dirt from Mars and look at it in the labs here on Earth, because the labs are always better than the instruments we can send there.
So are we really alone, or were we?
I think Mars, there's a big fascination with Mars because it has one of the best chances of us finding life besides other places in our solar system. That's been a big question that humans have had for quite some time, is are we alone in the universe? Another reason, I think, is we tend to be explorers as humans. We'll go out, centuries ago, thousands of years ago, we always explored new places. Mars is a close place and we can explore it. We know how to send missions there, so we have the capability to do that, so we send them there and see what there is there. I mean, can you imagine if we did find some other type of life on Mars? That would be pretty amazing. Another reason I mentioned earlier was that we need things to compare the Earth to. Why is our Earth situated in our solar system so that it led to life being on the Earth? If there's not life on other places like Mars, why is it not there? Why is the Earth the only place? And those type of questions really let us understand where we live much better.
Is Earth the only place in our solar system able to sustain life? And what would it mean to our world if we did discover life on Mars?
I don't know. I mean, it's never happened before, so the reaction to it, I know scientifically people will just really want to understand what it is. What does this life look like? Does it look like other carbon-based life that we have on the Earth? Does it look like something totally different? But the general response, I think, will be, I can't really know what it's going to be. I know it'll be an amazing thing if that was to be the case.
Bye.